In this lecture, we're going to dive into a crucial aspect of programming, error handling. Have you ever written a program and suddenly it just crashes because of some unexpected input or situation? That's where error handling comes in. It helps us make our programs robust, meaning they can handle unexpected situations gracefully without just giving up. This not only prevents our programs from crashing, but also makes them more user-friendly by providing clear feedback when something goes wrong. Let's start by talking about the two main types of errors we can encounter in Python: syntax errors and exceptions. Syntax errors are the ones we usually see when we make a typo or forget a colon or parentheses. These are caught by Python before the program runs, and it won't let the program execute until they are fixed. Now, exceptions are a bit different. These are errors that happen while the program is running. For example, trying to divide by zero, accessing a variable that doesn't exist, or reading a file that's not there. These are things that the program can't predict when it's being written, so we need a way to handle them while the program is running. To manage these exceptions, we use the try and except blocks. Imagine this as setting up a safety net. If something goes wrong in the try block, the program doesn't crash. Instead, it jumps to the except block to handle the error. Now let's get hands-on and practice with some examples. I have already created a new file called errorhandling.py for our examples. Let's start with a simple example. We want to divide two numbers, but we're not sure if the second number is 0. In this code, we're trying to divide 10 by 0, which is going to cause an exception. This code essentially says, try to do this operation. If this specific exception happens, stop what you're doing and handle the situation by doing something else. It's a way of telling Python, if everything goes smoothly, continue as planned. But if something goes wrong, like dividing by 0, don't crash the program. Instead, handle the error gracefully by executing the code in the except block. Here, the try block attempts to perform the division, but when it hits the division by 0, Python immediately jumps to the except block and runs the code there. Instead of crashing, our program prints a friendly message. Now, let's run this script and see what happens. We should see the output. Oops, you can't divide by 0. This shows us how our program handled the error gracefully. Now that we've seen how a simple try-except block works with a straightforward division by 0 example, let's move on to something a bit more complex. Imagine we have a list of numbers, and we want to divide a fixed number by each one in the list. Here's our list. We're going to loop through each number in this list and divide 12 by that number. But, as we've already seen, dividing by 0 will cause an error. To handle this situation, we'll use a try-except block to catch any zero division error that occurs during the loop. Let's break this down. We're looping through each number in our list with a for loop. For each number n, we try to divide 12 by n and print the result. This works fine for numbers like 2, 3, 4, and 6, but when we hit 0, Python raises a zero division error, which is caught by our except block. Instead of our program crashing, we print a friendly message saying, "Oops, you can't divide by 0. Now let's run this code. You'll see that for the first few numbers in the list, the program prints the result of the division. However, as soon as it encounters 0, the zero division error is raised, and the program immediately jumps to the except block. The loop stops right there, and the remaining numbers in the list are not processed. So the output looks something like this. This shows that the try-except block effectively handles the error, but it also interrupts the flow of the loop. If you want the loop to continue even after encountering an error, we'll need to adjust the code slightly, which we can explore next. Now, let's take this a step further. In our previous example, when the program encountered a zero division error, it jumped to the accept block and stopped processing the rest of the list. But what if we want the program to continue with the next number in the list, even if an error occurs? To do this, we can move the try except block inside the loop. This way, the program will try to execute the division for each number individually, and if an error occurs, it will handle it and then move on to the next number. Let's adjust our code to make this happen. What's different here? We've moved the try except block inside the for loop. Now for each number in the list, the program attempts to divide 12 by that number. If it encounters a zero division error, like when n is 0, it catches the error, prints the message, and then continues with the next number in the list. Let's run this code. Now you'll notice that the program doesn't stop when it hits 0. Instead, it prints the error message and continues dividing 12 by the remaining numbers. This approach allows us to handle errors gracefully without interrupting the overall flow of our program. It's especially useful when you're processing a list of items and want to make sure that one error doesn't prevent the rest of the operations from being completed. Sometimes different things can go wrong, and we might want to handle them differently. Python allows us to catch multiple exceptions. Let's expand our example a bit. Here, we're adding another except block to handle a value error. This might occur if the user enters something that isn't a number. Let's run this code. If we enter something like ABC, we should see the output. That's not a valid number. And if we enter 0, we'll get our previous message. Oops, you can't divide by 0. Obviously, if we enter a valid number like 2, the program will run normally and we will see the result of the division. This shows how our program can handle different types of errors in a specific way. Python also allows us to use an else clause with our try except blocks. The else clause runs if no exceptions were raised. This is useful if we have some code that we only want to run when everything goes smoothly. Let's run this and enter a valid number like 5. This time, since no exception is raised, we should see the output. The result is 2. The else block is executed because everything worked as expected. Notice that this part of the output corresponds to the result of this line in the code, while that part of the output comes from the else block. Sometimes we need to ensure that certain code runs no matter what, whether an error occurred or not. For this, we use the finally clause. This can be particularly useful for cleanup actions like closing a file or releasing resources. I'll add a finally clause to our code. Let's run this again. No matter what input we give, Whether it causes an error or not, we should see the message, "This will always run," printed at the end. This is our finally block in action, ensuring that the program completes certain tasks no matter what. Another thing to note is that the exception object in the except block might already contain a message. We can use this message to provide more detailed feedback when an error occurs. Let's modify our previous example to demonstrate this. In this version, we're catching the value error as an object E. This object contains a default message provided by Python, which describes the error in more detail. Let's run this code and enter an invalid number while it expects an integer. What you see here is the default error message from Python. Let's do the same with the zero division error exception and catch it as an object E, and add the exception message here right after our message. If I run this, you'll notice that along with our custom error message, the output also includes the default error message from Python. By incorporating the exception message, we provide more context about what went wrong, which can be helpful for debugging or providing more informative feedback to the user. There might be times when we want to raise an exception intentionally. This can be useful if we want to enforce certain conditions in our code. We can do this using the raise keyword. In this code, we're checking if the input is a negative number. If it is, we raise a value error with a custom message. Let's run this and enter a negative number like -5. We should see the output, "Negative numbers are not allowed," coming from this except block. This shows us how we can control the flow of our program by raising exceptions when needed. To summarize, in this lecture, we've explored the basics of error handling in Python. We started with the importance of error handling to prevent program crashes and make our programs more robust. We covered different types of errors, including syntax errors and exceptions. We then looked into the try and except blocks to catch and handle these exceptions. We also discussed handling multiple exceptions, using the else clause when no exceptions are raised, and the finally clause to ensure certain code always runs. Lastly, we learned how to raise our own exceptions to control program flow. That's it for error handling. With these tools, you can make your Python programs much more reliable and user-friendly.